Hi everyone. Before, we used the standard deviation and the 2SD rule to develop a usual or realistic range of values. Now let's do it in reverse. How would we use a usual or realistic range of values to estimate a standard deviation? So let's say that I, the professor, browsed through the 1,000 test scores from a class test. So I see these stacks of exams that Igor has graded. I looked through and I noticed that the vast majority of the scores, maybe almost all the scores, are between 30 points and 70 points. Now, if I assume that the distribution is approximately symmetric, not necessarily bell-shaped, but at least approximately symmetric, then I could estimate that the population mean is 50 points. So if I assume approximate symmetry, then if the usual range, the realistic range, is going from 30 points to 70 points, then my symmetry, I can assume that 50 points is the mean. That's right in the center. It's the midpoint between 30 points and 70 points. Again, I'm not necessarily assuming a bell-shaped distribution, but I'm at least assuming approximate symmetry. So let's estimate the standard deviation. Well, starting at the mean, 50 points, right? We would walk 2 standard deviations to get the 70 points over here, and we'd walk 2 standard deviations to the left to get the 30 points over here. So we have a total of 4 standard deviations, 4 sigma, separating the lowest score and the highest score in the usual or typical range of values, the realistic range. The realistic range would be between 30 points and 70 points. The realistic range would be 70 minus 30 points. 70 minus 30 points. Now, the range of the data set would be, strictly speaking, the highest score minus the lowest score. But we don't want to bother ourselves with outliers, so we want to think about the vast majority of scores. At the highest end, 70 points. At the lowest end, 30 points. The realistic range, sort of the usual or typical range, would be 40 points. The idea is that very few of the scores should be less than 30 points or greater than 70 points. Okay, so 4 sigma is about 40 points. 4 sigma is about the realistic range. If you divide both sides by 4 and turn this thing around, 4 sigma divided by 4 is just plain old sigma over here. And over here we have the realistic range divided by 4. So our estimate for the standard deviation sigma is going to be, it'll be about the realistic range divided by 4. So in our test example, the realistic range was about 40 points, 70 minus 30 points. Divide that by 4, we get 10 points. The idea is that the picture here is like the picture we saw before, where the standard deviation was assumed to be 10 points. So let's do another example from scratch. So let's say that you browse through the website for a campus bookstore, and you think that the vast majority of the textbooks in a campus bookstore have prices between $20 and $180. Based on this, estimate sigma, the standard deviation of textbook prices in the bookstore, the population standard deviation. And it'll be a ballpark estimate. I'm not claiming that it'll be precise, but let's just get a ballpark estimate. I mean, what do you think? Do you think it might be 4 cents, $4, $400? What's even the order of magnitude we're talking about? All right, so if realistically the prices are between $20 and $180, we're not going to bother with outliers, then the realistic range is going to be $180 minus $20, or $160. We divide that by 4. The realistic range, $160, is divided by 4, and we get $40. Don't forget the unit, dollars. So based on this observation, we're estimating that the standard deviation is about $40. Now, it may not be precise. Maybe it's $30, maybe it's $50, but I doubt that it's $4 or $400, assuming that your observation is reasonable up here. Roughly, we're talking about this ballpark. Just to get an idea of what the standard deviation is, broadly speaking. Okay, again, it's a very rough estimate, but we think that the standard deviation is more likely to be about $40 than, say, $4 or $400 or 4 cents. One final comment about standard deviation. Investing. What do most investors, right, and investment firms suggest that you do with your portfolio, your investment portfolio? They usually suggest that you diversify your portfolio. And what does that mean? What does it mean to diversify your portfolio? It means that you should have a bit in stocks, a bit in bonds, a bit in cash. As far as the stocks go, you should have a bit here, a bit there, a bit there, a bit there, right? Have your money spread around a whole variety of stocks. Don't invest everything into one stock, because that stock, while it could be Apple or Microsoft, it could, on the other hand, be Enron. There's a big story with that. Diversify your portfolio. This is because most investors tend to be risk averse. Most investors are risk averse. Now, if you want to get rich quick, then you might be risk seeking. But most investors are risk averse, meaning that they're hoping that the stock market, I'll use the Dow Jones as a measure, but that's very debatable, right? Dow versus time in years. Okay, and maybe this is the year 2000 or something. Now, of course, we had a dip in 2008, but let's smooth it out, all right? The idea is that in the long run, we hope and believe that stocks will pretty much follow an exponential curve. Now, of course, it's not quite that smooth. This is very smoothed out. But let's say that the stock market grows at about 8% a year, and let's smooth it out. So we get what kind of a curve? What's that E word from your algebra class? That J curve, exponential. We're assuming that stock prices overall will grow exponentially. I'm talking about a whole cluster of stocks, not necessarily one stock. A single stock can go up, down, up, down, up, down. I'm talking about the stock market in general. And the hope is that your portfolio, your investments, will pretty much follow that J curve. Sometimes you'll do better, sometimes you'll do worse. But the idea is that you want to pretty much follow the stock market, and you want to reduce variation. You want to pretty much follow the stock market. Now, if you want to get rich quick, if you want to get a curve that looks like that, then you might have to be very smart in picking stocks, invest in a few stocks. Maybe you want to be risk-seeking, and you're not interested in diversifying your portfolio. But most investors are risk-averse. They want to diversify their portfolio so that if one or two components totally fall apart, you won't be broke. You'll have something in something. All right. So the benefit of a diverse investment portfolio is that risk is spread out across many instruments, stocks, bonds, cash for that matter. Although cash loses value over time because of inflation, the hope is that stocks will beat inflation overall, right? 8% usually does beat, 3% or so inflation. But, you have to understand that cash itself loses value over time. In fact, that's one theory as to why in the times of coronavirus, people are parking in stocks because, bonds aren't doing so hot and cash loses value inevitably. But you want to diversify so that no single investment will destroy you if it sinks, or no single group or type of investments or instruments. Your hope is that your portfolio will at least keep up with inflation. It usually does. Again, on average, the Dow grows about 8% a year. Inflation has been about 3% a year in recent decades. And you're hoping that in general, even though you'll go up and down and the market goes up and down, you're hoping that you will generally, hopefully follow an upward trend of the market over time, which is hopefully a J curve smoothed out over time. I've mentioned Excel before in previous videos. Here's some sample commands. Okay, next up, let's try to draw some pictures and think of a few summary numbers that can describe our data. Next time.